The Three Gorges Dam is a dam built in China, finished in 2009. It was the largest dam in the world upon its completion. And here's all the numbers, how long it was at the top, how long it is at the bottom, and how high it is. Assume the dam is the shape of a trapezoid. If we don't assume that, it becomes a very difficult problem. Now we're going to calculate an integral that gives a total force of the water on the dam. So this is going to be hydrostatic force, total force of the water on the dam. Now, if I draw my little trapezoid, we have to assume some things about it. That this bottom piece is right in the middle. So if I draw these two lines right here, these two triangles on both sides are the same. Without that, again, it makes it very hard to do the problem. So the total length of the top, we said, was 6561.68 feet long. The bottom is 5577.43 feet long. And the height of the trapezoid is 590.55 feet long. Now in this problem, hydrostatic force, we have to assume that water is 62.4 times H, or the depth that you're at, pounds per square foot. And if you want to know why that's true, go watch the video regarding the lobster tank. And that'll explain why I'm using this as the water. Now, when I slice my dam, I want to slice it so that the force on that slice is going to be the same all the way across. So, you know, the deeper you are, the more force you have on that slice. So I pick my random slice, and I have to think about how to calculate the force on that slice. Now, the force on that slice is the density of water on that slice times the area of the slice. Now, how do I know that? Well, I want force to be pounds in the end. I look at unit of measure. The density of water is pounds per square foot, and area is square feet. So you notice that the multiplication of those two areas is going to get me the pounds that I want in the end. Every time you do these problems, you need to think about stuff like that. Try not to jump from beginning to end thinking that you have the answer. You must think about it, because we can make small changes and it makes the problem different enough where you can't do the same thing every time. Now, because of the way we define this H, we have to measure the slice from top down. When you measure the depth of something in water, you don't measure from bottom up. We always measure from top down. Even in the real world, it's that way. So let's talk about the area of my slice. Well, because it is so thin, it's pretty much a rectangle, and that's going to be length times width. The width of my particular slice is going to be the change in H, or delta H. And that means all we have to do is figure out how to describe the length. Now, the length all the way across is going to change depending on where I slice it. If I slice at the bottom, it's going to be short. Slice it at the top, it's going to be longer. And it varies all the way up and down. So I have to figure out a way to describe L in terms of H in order to make my area work right. Now I'm going to mess around with this L thing down here at the bottom so I can draw lots of pictures, and I'll come up to the top again. Okay, now here is my, let me go up a little further. Here is my trapezoid. And here's my slice. And L is the distance all the way across. Now, if I draw the two vertical lines here and here, because the way we're assuming the trapezoid is, I can say that that length there, A, and this length here, A, is equal. As is this length here is equal to this length here. Now, I know the bottom length is 5577.43. That means, since these are perpendicular to the ground, that this length here is 5577.43. That means that this distance from here to here, 5577.43. So if L is the distance all the way across, we can say that L is equal to 2A plus 5577.43. So now let's take a look at the value for A. If I draw the triangle here, these two triangles, by the way, are exactly the same, just by nature of the trapezoid. This length is A, this length is X, this length here is H, and this length here is 590.55. 590.55. Now, the only thing, if I'm going to use similar triangles, I'm going to have to say X is to A as this long side is to this short side. So I need to figure out how to describe the short side. Now, if I want to describe this, the whole length is 590. And if I take off this length H, the remaining bit will be left. So it's going to be 590.55 minus H. Now, using similar triangles. A is to X as 590.55 minus H is to 590.55. Now we have to figure out a value for this X right up here. This total length here is 6561.68. So I know that if I take 2X plus 5577.43, that's going to equal the length of that total side, 6561.68. So if I subtract this number from both sides, divide by 2, I should get my X value. So let's do this in the machine here. 6561.68 minus 5577.43 divided by 2. 6561.68 minus 5577.43 divided by 2, 492.125. So X is 492.125. So that means down here I can say A is to X is equal to 590.55 minus H, or 590.55. Again, we really want to solve for A because that's what all we need right here in order to write L as a function of H. Now remember, we want to write L as a function of H because of that guy right there. The width of my slice is delta H. So this whole thing has to be in terms of H. All of this has to be in terms of H. All right, coming back down here. I have A is equal to 492.125 times 590.55 minus H divided by 590.55. Now that's not at all pretty, but that's okay. We can try to simplify it a little bit if we'd like, just to make it nicer. So say I divide 492.125 by 590.55. Need some space here. So 492.125 divided by 590.55. And we get 0.8333. So this is going to equal 0.8333 times 590.55 minus H. Distributing that. So multiply this by 590.55. So 492.125. 492.125 minus 0.8333H. Doing some algebra on this always helps when you have to have lots of numbers and you have to do something with it later. It does help. So up here, I know then my L is going to be 2 times 492.125 minus 0.8333H. And then I have to add 5577.43. If I want to simplify that more, Distribute the 2. So 2 times 492.125. 984.25 minus 0.8333 times 2. 1.46 H plus 5577.43. So then in order to make this as simple as possible, I just have to add those two numbers together. So 984.25 plus 5577.43. I get 6561.68 minus 1.6666H. Now that's my length for my particular trapezoid in this dam. Now these numbers aren't pretty. That's because it's a real dam. We're using real numbers, not just pretty stuff. So I have to take this guy right here, which is what L is. If I follow the equal signs back, it brings me back to L. And I need to put him up here in L right here. So that's going to equal 6561.68 minus 1.666H, delta H. Now if I go back to my force on my slice, that's going to be the density of water, 62.4 H times the area. I'm probably going to run out of room here. 6561.68 minus 1.6666 H. And we're going to put our delta H in here because, like I said, I ran out of room. Finishing up this problem. Let me move it over a little bit. I don't know if I want to distribute all that. I'm not gonna. Let's just talk about the integral. 62.4 H 6561.68 minus 1.6666 H dH. Now all I have to think about now is my limits. So if I think about the lowest or the biggest H or the smallest H, however you want to think about it, if my slice is way at the top and I calculate the force there, H is going to be 0. And if I calculate the force on when the slice is at the very bottom, H is going to be 590.55. Now, if you take this integral and enter it into the calculator, you will come up with something very close to the answer that I have here. 6.4258 times 10 to the 10th pounds. That's a lot of force on that dam. So there you go.